Hope you all are doing very well. We are making this video as part of our college assignment for the subject software testing and quality assurance. There are total 4 people involved in this project, and we have guided by our instructor, Mr. Peter Sigurdsson. So let's get started. So in this video, we will talk about the different aspects of the software development. So in this video, we'll talk about the software development lifecycle, what is software testing and why we need software testing, what is software testing lifecycle, what is different software testing methodologies, what is software quality assurance and testing, what is different kind of SDLC methodologies, and in the SDLC methodologies, we will talk about the free model, Agile, and what is agility, what is agile principle and values, and then after we will talk about the unified process, and in the last we will talk about the JUnit, like it's introduction of the JUnit. So let's get started with the software development lifecycle first. So what is software development lifecycle? So software development lifecycle is nothing but the step-by-step procedure, or we can say the business procedure to development of any software. So what we do in the software development lifecycle, there are different steps involved for the software development, and so what is the aim? So aim is to produce quality software as per the system's requirement. So in the next slide, we will talk about the different phases of software development lifecycle. So and the first stage of the software development lifecycle is the requirement collection. And in the requirement collection, what we gather all the requirement from the customers or the users. What do you mean by the customer and users? So as you know guys, there are two types of companies. One is service based companies and another is the product based companies. So which are the software based service based companies? So like we can say Accenture, Tata Consultancy Service, Wipro, Infosys. These are the service based companies, while the Google, Facebook, these are the product based companies. So we gather the requirement, for example, in the service based company, I'm talking about the service based company. So for example, there is one customer, the customer from bank. So he will go to the service based company that I have to make this kind of software. So the business analyst will take the requirement from the customer, that what kind of software you have to make. So he will take all the business requirements from the customer, and then after he will come to the company and then convert that requirement into the business requirement into the technical requirement. So then after, when he will come to the company, they will do the feasibility study along with the other stakeholders. Which are the other stakeholders? Like there are a product manager, then there are a finance team, then there are a HR, then the other technical teams, design architect, all the people do the feasibility study. What kind of feasibility study they will do? Can we make this software with this budget? We have different kind of budget, so finance people will talk about like finance related thing, budget related thing. Then after program manager, product manager will talk about the different product related. They will discuss about the different product related thing. Then the HR will talk discuss about they have enough manpower or not, they have enough lab setup or not, they have enough technology or not. So they will uh, discuss about these things, and then after uh, discussing all of these things, they do the feasibility study, and then they decide that they have to take this project or not. So once they decide that we will take this project, then after it will go into the design phase. So in the design phase, a software architect will convert that business requirement into business analyst already converted the business requirement into the design in the technical uh, requirement. So like developers, quality engineers, and the design architect can understand the thing. So now design architect will convert uh, that requirement into the actual design. So there are two type of design, like a high level design and the low level design. What is the high level design? Like we can take the example of Gmail application. So in the Gmail application, if we see like inbox, sent item, compose, then the spam, then the trash, all of these are the high level design. What is the low level design? So like if we are sending the email to someone, then from the, so we are sending like from to, then the BCC, CC, the subject, and the content and the attachment. These are the low level design. So he will design the all the uh, he will design the low level design and high level design, and then after uh, developers will do the coding according to the high level design and low level design. After coding, tester will test code. How they will test the code? They will test the code according to the requirement given by the customer. That requirement is given by the business analyst to the test team and also the developer. So test team will see that the software developed by the developer is according to the system's requirement. They will test the software, and if there is any defect, if there is any bug, then they will send the software back to the developer team, and they will resolve that bugs, and then after they again send to the testing team, quality team, and then after they again check the according to the system's requirement, and if the software is working fine, then after it will go into the deployment. So they will deploy this software, and then after they will hand over to the customer, and then after the last stage is the maintenance. So what is software testing and why we need software testing? So software testing is nothing but the step-by-step procedure to ensure that the actual software product is matches with the system requirement or not, and the final product is bug free. So like what is the purpose of the software testing actually? So we identify the errors and gaps or missing requirements in contrast to the actual needs. So let me tell you one example why we need software testing. Let's say I have one small application where I can upload the medication prescription, the prescription from the doctor, and then after according to the prescription, we are just sending the medication to the user's address. So what, like because of the software defect, if I wrongly send the wrong, like I send the medication wrong on the wrong address, and if the user doesn't know that this medication is according to he ordered or not, then what happened? Maybe he will take the wrong medication, and maybe it is hazardous, like it is dangerous to his or her health. So this kind of problem will happen if we do not uh, test the software. So that's why the software testing is very essential part of the software development. So in the next slide, I will explain the software testing lifecycle. So first phase of the software testing lifecycle is the requirement analysis. What kind of requirement we analyze in this stage, in this phase? So we analyze and study the requirement first, and then after we like test the requirements, and we check whether which uh, case is testable or not, and then after we identify the scope of the testing, and if any feature is not testable, then we just communicate with the developing team, and in the next phase we do the test planning. What we do in the test planning, we we see the we first of all the identify which environment and which tools we will use, and then after we plan that how many engineers we will need in the particular test in the testing, and we define the different, like we convert the whole software into the different modules, and like testing modules, and then after we will give that particular module to which test engineers will perform the testing on which module. So we will do this kind of planning, like the tools related planning, what how many manpowers I will need, and then after how many which test engineer we will do which module testing. So that kind of planning we will do in the test planning, and then after we will do the test case designing. So what we do in the test case designing, first of all, we identify all the scenarios. For example, if I have a login screen, so what are the possible scenario for the login screen? Like if I enter the username and I enter the password, and when I click on the login button, it will go to the next page. And what happen if I will enter the wrong username or password? So it will show the warning that username or password is incorrect. So these are the possible scenarios for the particular login page. So we will identify all the possible scenarios in this phase, and we will write the test cases depending on that all the possible scenarios, and then after we will review our test cases. Okay, and depending on the test cases, we will write the traceability matrix. Requirements traceability matrix. What is requirements traceability matrix? So in the traceability matrix, in the x-axis we write the test cases, on the y-axis we write the uh, requirements. So the relation between the requirements and the test cases is many to many. So how? So we identify that each and every requirement has at least one test case, and one requirement has more than one test cases as well. And like that, one test case is mapped into the more than one requirement. So relationship between the test cases and the in the requirement is many to many. And after writing the testability matrix and all in the design test case designing phase, we will do the environment setup. After doing the environment setup, we will do the test execution. So in this phase, we do actual test execution. So how we will do test execution? We already have the requirement. We already written the test cases. Now we have a software. So we check that this particular software is working according to the test cases. Like for example, we are testing the different features of software, right? So now we already have test cases. So we like uh, we check that this test cases this software in the software we are testing different test cases. And after check testing all the test cases, if we find any defect, like for example this particular test case is not working in this software, then uh, then we write the bug report. Like we it's kind of defect. So according to that according to that defect, we will write the defect report, bug report or defect report. And if all the software is working according to the requirement, according to test cases, then we write whole report over there. This test cases is working fine, this test case is not working, this is this test case has a defect. So we will send whole report, and we will write whole report, and then after we will send the report to the business analyst. And if there is any defect in the software, so we'll they will send it back to the developers. They will again check the requirement, and they will write coding and do again, and then after again they send the whole software to the testers, to the testing team. And then after they again test the software according to test cases, according to the requirement. And then after doing all this process, if there is no any defect, then we will write the test closure report. And that is how the testing software testing lifecycle work. So these are the main methodologies of the software testing. Two, there are two type of testing, mainly classified into two categories. One is the functional testing, another is the non-functional testing. Which testing comes under the functional testing? So the unit testing, integration testing, system testing, acceptance testing. These are comes under the functional testing. Performance testing, security testing, usability testing, compatibility testing. These are comes under the non-functional testing. And in the next slide, we will explain the which are the functional testing and non-functional testing in details. So functional testing. So there are four types of functional testing: unit testing, integration testing, system testing, and acceptance testing. So what is the unit testing? So as we know, in any software in the background, what is it is called coding, right? And in the coding, there are different kind of classes, methods, and function and all. So these are the smallest unit of any software, and testing of this smallest unit is called unit testing. Who do this testing? Developer do this testing. Then integration testing. So we divide whole software into the smallest modules. So now these modules communicate with each other in software. Like for example, there is a Gmail application. So what is the different modules in the Gmail application? Like inbox, sent item, then compose, and all. These are the different components of the Gmail application. And now if I am composing any email and if I'm sending the email to someone, then it will goes into my sent item. So this is the communication like between the compose and the sent item. So this is called the integration, and this is called integration, and testing of this thing is called integration testing. Okay, and who do this testing? Developers do this testing. Then the system testing. What is system testing? System testing is the testing of whole software product. So testers do this testing. In this testing, what we ensure that the our final actual product is according our system's requirement. So testers will take the system's requirement first, and then after they check each and every features of the application, each and every features of the product, and then after if there is any defect, then they send this a product back to the developers that there is a defect, this is the requirement, but this software is not behaving actual according to the requirement. So they will resolve that bug, they will resolve that defect. Then again they developer team send this thing to the testers, and then tester again test the same product, and then after if there is no any bug, then we can deploy the software. And in the last, the acceptance testing. What is acceptance testing? Acceptance testing is done by the user, done by the customer. So when we deliver the final software product to the customer again check it is from their end. They take the requirement, they check according the software is behaving according to the requirement or not. If it is working fine, if it is working according to the requirement, then they will do the deployment. Otherwise if they find any kind of bugs, or they find like if they don't like any colors of, or they don't like any kind of feel of the software, then they will again send the software back to the company, and again we need to resolve the any kind of defects set by the customer, and again we need to test it again, and again we will send the software back to the customer. Now again customer will check the software, and if they like the software, then they will do the deployment. So this is called acceptance testing. So the unit testing and integration testing, this both are done by the developers, and that's why it is called white box testing, because developers knows what is the inside the software. So that's why we call it white box testing. While the system testing is done by the quality assurance team. Acceptance testing is done by the customer. So quality assurance team doesn't know that what is the internal structure of the software. Acceptance testing done by the user. They don't know what is the internal structure of the software. So it is called black box text testing. Next is the non-functional testing. So there are four types of non-functional testing, and they are the performance testing, security testing, usability testing, and compatibility testing. What is performance testing? So in the performance testing, we check the load. Like when like there are we check the load is how we check the load, how many number of users or data can software take at the same time. So it can be classified into load and stress testing as well. And load testing verifies if the system can operate at the required response time when putting on the load. And also stress testing find the failure point of the application where the system crashes. Again there is a security testing. What we check in the security testing, so with the increasing the risk of the cyber attacks and the cloud-based testing platform, uh, the need of the securing the data and storing it in the software is a growing concern. And so we check the any kind of loopholes and security breaches that can be result into the unauthorized access or loss of the secret data. So we do this kind of testing in the security testing. And what is usability testing? So in the usability testing, we check the whenever we try to access any software or any application, we like what is the feel, what is the it's kind of user experience testing. So how we feel whenever we are using this software. So these are the five factors we will test in the usability testing. It's learnability, efficiency, satisfaction, memorabilia, and testing of the application as in the end user by logging into it. And in the last, it is compatibility testing. What we do in the compatibility testing, we check the whether the software is working compatible with the specified operating system, hardware platform, web browser, mobiles, or any other kind of third-party plugins. So this kind of testing we do in the compatibility. Software development lifecycle methodologies. So these are the top software development methodologies. First is the waterfall model, or we can say the basic model. Another is the verification and validation, or V model. Agile, DevOps, unified process, lean prototyping model, iterative and incremental development, spiral model. So in this video, we will talk about the V model and Agile. So in the next slide, we'll explain what is the V model and why we use V model. So basically, the waterfall model is the same as the software development life cycle. And what is the drawback of the waterfall model is that whenever we receive the requirement from the customer and we convert it into the system's requirement, then after converting it into the system requirement, after the feasibility study, we cannot change the requirement. So we are not flexible to change with the waterfall model. And so in order to overcome that problem, we have developed the V or like a verification, validation, or V model. So what is the basic biggest advantage of V model is that we are doing testing at each and every level of the software development. So it demonstrates the relation between each phase of the development lifecycle and it's associated with phase of testing. Testing is planned along with the development. So both the testing and development is done at the same time. So we do the planning of the testing along with the development. So one phase is the verification and another is validation. So first is the verification stage. So and the first stage is the requirement. So in this stage we are doing the requirement gathering as in like in the waterfall model. What kind of requirement gathering? So we just do the gather the requirement from the customer first. We take all the systems requirement, all the software's requirement, business requirement. So what who will do this requirement collection thing? Business analyst. Business analyst gathers all the requirement from the customers in the business language, and then after they will come to the company. They convert that business requirement into the systems requirement specification. So they he get when they gather the requirement, the test engineers will do the testing. What kind of testing they do? Like they will develop the acceptance test plan, and they develop the acceptance test plan. And if he find any kind of they find any kind of defect in the requirement gathering, then they directly communicate with the a business analyst. If then after the business analyst convert that business requirement into the system requirement. So business analyst now will give the information to the both the developers and the tester. And testers, what tester will do? They will develop the test plan. They will do the they will develop the test plans. Test okay. And then again, according to the requirement, they convert that requirement into the design in the architect. So who will design convert the design requirement into the design? Architect. Architect. convert that requirement into the design. And again, the test team again to verify the same thing, and they again uh, develop the architecture design testing plan. Same thing. Now there are two type of designs: high level design and low level design. So again, test team verifies the both kind of designs, and they made the plan. Again, they now according to the design developed by the architect, developers do start doing coding. So now after the coding, developers will do the unit testing. How they will do unit testing? They will do unit testing according to the low level design plan, a low level design plan made by the architect, and the test plan, low level design test plan made by the test team. So they will do the unit testing. What is unit testing? And the unit testing, they do the testing of the smallest part of the coding, like classes, methods, and the functions. These are the smallest unit of the coding, and they do the testing of that coding. Then there is integration testing. So what they do in the integration testing, and they the test team has made the plan according to the high level design. So according to high level design, they made the test plan. Now they test the high level design, high level coding with the um, like they do the integration testing. What is integration testing? So integration testing are performed by the uh, developers first, and then they what would how they do the integration testing. So the whole software is divided into the different modules, and now these modules are communicating with each other in the system. So these modules are communicating with each other properly or not. They do this kind of testing in the integration testing. Then after system testing. So in the system testing, test teams do the testing of whole system, whole software. So they test how they test. They already made the test plan. They already made the test cases. They already made the testability matrix. So they already made all the test case scenarios. Now they have systems requirement. They have specification, and so they they check that this requirement, like this software is working according to the system requirement specification or not. So they do the thorough testing of the whole software. If they find any kind of bugs and all, they convert that. They will communicate with the development team that we find this bug. They will like prepare the report, and then developer team again resolve the issue, and then again they send the whole software to the test team. Testing test the software again. If there is no any kind of bugs, then it will go into the next stage. It's acceptance testing. Acceptance testing done by the customer or done by the test teams. How they do the acceptance testing? They see the what is the business requirement. So the software is behaving, the software is working as per the system's requirement or not. If it is working exactly like the business requirement, then they will pass the software, and then they will uh, deploy the software. So why we use V model? Like why they developed a V model to overcome the problem of the waterfall model. In the V model, we do testing in each and every first phase of the software development life cycle. So the final product we will get is the more uh, with the more quality, and so we can deliver a quality product to the customer. And the next slide, I will explain the agile. So what is agile? So in software development, agile is the iterative approach to project management and software development that helps teams deliver value to their customer faster and with fewer headaches. Instead of betting everything on a big bang launch, an agile team delivers work in small but consumable increments. So like what we do in the V model and in the other kind of models, we deliver the whole software to the customer. But in the agile, what we do, we deliver the small but consumable increments to the customer. It involves discovering the requirements and developing solutions throughout the collaborative efforts of self-organizing and cross-functional teams and their customers and end user. So what is basically agile? So in the agile, all the stakeholders like developers, project manager, business analyst, testers, customers, all the stakeholders work together, all the and they to provide a better service, better software to the customer or the end user. It advocates adapting planning, evaluatory development, early delivery, and continual improvement, and it encourage flexible response to change. So this is one of the biggest advantage of agile. So what is the problem with the other kind of model is that once we get the planning from the customer and when we do the feasibility study and when we convert the business requirement into the system requirement, we cannot change the requirement. But agile is very flexible, and if customer is saying that I have to change this requirement, then we can change the requirement. So agile is very flexible to respond to change. So in the next slide I will explain what is the values and principle of the agile. So what is agility? Effective response to change. What is effective response to change? So we can change requirement between the software development. It is not possible in the other models, but we can change the any kind of like if customer says I have to change this requirement, we can change the requirement in the other. Effective communication among all the stakeholders who are involved in the project, like project managers, then the business analyst, developers, testers, all the people. The communication between these people are more important, and so in agile and the effective they take care of the effective communication between these all the stakeholders, drawing the customer into the team. So we have, as we know, like we have to deliver the software to the customer. So if we involve customer also in our project, then if customer need, like if they need to change any requirement or if they don't like any kind of like experience, user experience, customer experience, then they directly draw your attention towards it and we can change on the at the same point. Organizing a team so that it is in the control of the work performed to yield rapid incremental delivery of the software. So what is it like? We organize that kind of team. So like as the communication between these teams are good, and if we draw a customer into the team, and if we organize the corporate team, so we can deliver the software, our software product fast. Okay, so what is the there are four agile software development values. First value is that individual and interaction over the process and tools. So individual and interaction. So what is individual? Individual means all sort stakeholders, like a product manager, then the business analyst, developers and testers, and the communication between them are more important than the processes and tools. Okay? Next is working software over the comprehensive documentation. Yeah, documentation is important, but working software is more important. If we deliver working software to the customer, then customer will be happy. We can do the documentation part after that. Okay? Customer collaboration over contract negotiation. So in Agile, we also uh, take a customer also take a part in the development life cycle. And so if customer want to change any kind of thing, let's say like why customer want to change any kind of thing or they want to like change anything, then they directly can communicate with the software development team. Okay, responding to change over the following a plan. So what is responding to change? This is one of the biggest advantage of agile. So we can change the requirement at any level of the software development. Let's say like we are in the field of technology, right? And technology is changing at day-to-day basis. Like for example, if I'm using WhatsApp, and before 1 year ago, the WhatsApp was different than what I'm using today. So if customer has given us a requirement that I have to build this kind of software, and after like 2 to 3 months, if there is new technology introduced in the market, and if they want to introduce that into the software, if we are giving the flexibility to the customer that you can change your requirement in between the development, then that will be the one of the biggest advantage in the technology field. So that's why the agile is one of the uh, modern software development technology, and most of the companies are using this model. These are the 12 principles of the agile software development. So first is customer satisfaction by early and continuous delivery of the valuable software. So in the agile, what we do, we deliver the not a whole software at the same time, but we deliver the small and continuous delivery of the valuable software. Welcome changing requirement even in the late development. So we can change our requirement as well in between the software development. Deliver working software frequently. So we are like every week or every month or every week or every 10 days or every 10, 20 days or every month, we deliver the working software. Close daily cooperation between the business people and developers. So effective communication between the each and every stakeholders. Projects are built around motivated individuals who should be trusted. So the people like the testers, the developers, then the business analysts. These are the like motivated. They motivate these people. Face-to-face conversation in the best form of the communication. Working software is the primary measure of progress. Sustainable development able to maintain the constant pace. Continuous attention to technical excellence and good design. Simplicity, the art of maximizing the amount of work not done is essential. Best architecture, requirement, and procedures emerge from self-organizing teams. Regularly, the team reflects on how become more effective and adjusts accordingly. So these are the 12 principles of the software, agile software development. So next is the unified process. What is unified process? Unified process is architecture-centric, use-case-driven, and iterative and incremental development process that leverages unified modeling language, UML language, and it complement with the system process engineering meta model. Popular iterative model process model framework derived from the UML, Unified Modeling Language, and associated process. Unified process is the leading object-oriented methodology for the development of large-scale software. These are the features of the unified process. Map out when and how to use the various UML techniques. Develop high-risk elements in early iterations. Deliver value to the customer. Which are the unified process phases? First is the inception. So establish the business case for the system, define risk, obtain 10% of the requirement, and estimate the next phase effort. Elaboration. Develop an understanding of the problem domain and system architecture. This risk significant portion may be coded or tested, or 80% significant requirement identified. Construction. System design, programming and testing. So system design is according to the customer's requirement. Programming and testing. Programming is according to systems requirement. Then after the architecture design, and then after the coding, and then the testing of the programming. Building the remaining system in short iteration in the short time. Transition. Start when the data testing is completed. Deploy the system and its operating environment. Deliver release for the feedback and deployment. So what we do, like first test after the completion the testing, like beta testing. Then after deploy the system in the operating environment, and then after we take the feedback from the customer, and then after again we do the deployment. Like we update like first beta and then after the final release. So what is the JUnit? This is just introduction to JUnit. JUnit is the testing framework of the Java programming language. JUnit has been crucial in developing test-driven development and one of the family of the JUnit testing framework collectively known as XUnit that originated with JUnit. So what is basically JUnit? So JUnit is as I explained earlier, there are different, like in the coding there are different units. There are small units. We divided which are the small units? Class, then the methods and function. So in any software, there are thousands of these kind of classes and methods and function. If we test this function and classes by manually, then it will take a lot of time. So with the help of JUnit is the framework of Java programming. So we can implement the JUnit inside the Java. Okay, with the help of Java. So this is kind of automate. Like we need to write a script for that. When we write the script for that, it will do the automatic testing of each and every individual unit of the software of the individual. This approach is like test a little, code a little, test a little, code a little. So like I have the whole software. I'm developing the simple the smallest unit like a class and methods and function, and then after I will do the testing of that by writing the script for that. And then after again I will code again I will write the test cases for that, like the small test cases, and then after again I will do the code. I will do the testing. Again I will do the coding, then testing, coding, testing. It increases the programmer's productivity and stability of the program code, which in turn reduces stress on the programmer and the time spent on the people. So when we do JUnit, like when we do unit testing using JUnit, what 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 is the advantage of it is that we can increase the program's productivity and the stability of the program as well. So we can reduce the time on the debugging. What are the features of JUnit? JUnit is an open source framework which is used for writing and running the tests. Provides annotation to identify test methods. Provide assertion for testing accepted results. Provide test runners for running tests. JUnit test allows you to write codes faster, which increase quality. JUnit is elegantly simple. It is less complicated and takes less time. JUnit test can be run automatically, like if we can write the script, not a script, but we can write the codes, Java codes for that, and we can run it automatically. And they check the result and provide immediate feedback. There's no need to comp through a report to test result manually. JUnit test can be organized into the test suites containing test cases and even other test cases suites. JUnit shows that test progress in the green bar if the test is running smoothly. So whenever like we write any test case for the in the JUnit for the particular unit, then if that unit is passed, then it will show the green bar and it turns into red when test fails. So if I write a wrong code, then it shows the red bar. So what is the conclusion? What is the learning outcome from this video? First, throughout this presentation, we'll learn about the different aspects of the software development, like software development lifecycle and its different methodologies. We also learned what is software testing, why we need software testing, why software testing is essential part of the software development. We also learned different type of software testing lifecycle, different kind of testing we need to ensure the quality of the software uh, product according to the system's requirement. Additionally, we also learned about what is Agile, what is its value and principles, what is unified process, and also about the basic introduction of the JUnit. So thank you for watching this video. If you like this video, please hit on the like button. Thank you. Have a good day.